Okay, multi-step conversions involving moles. For example, how many molecules are there in 5.20 grams of glucose? Here we want to get from grams to molecules, and to do that we have to go through moles. In other words, there's two steps. I have to convert grams to moles and then moles to particles. Before we get to this, let me introduce you to what I call the stoichiometry diagram, or the mole map. This map maps all the conversions necessary involved here. For example, this one we want to go mass to moles and then moles to particles. But first, again, let's take a look at this map. Moles are the central unit, and if I want to convert between moles and particles, the equivalent is 1 mole equals Avogadro's number. If I'm going from moles to particles, then the equivalent is Avogadro's number over 1 mole. If I'm going from particles to moles, then the equivalent is 1 mole over Avogadro's number. So always what you're converting to on top. If you're converting to particles, you want Avogadro's number of particles on top. If you're converting to moles, you want moles on top. But again, this is the equivalent to convert between moles and particles. To convert between moles and mass, the equivalent is 1 mole equals the molar mass from the periodic table. So if I'm going from moles to mass, then I want the molar mass in grams on top, 1 mole on bottom. If I'm going the other way around from mass to moles, then I want 1 mole on top and the molar mass on bottom. And if I want to convert between moles and liters, the equivalent is 1 mole equals 22.4 liters. So let's get to our problem here. How many molecules are there in 5.20 grams? So I'm giving you grams, asking for molecules. So I'm giving you grams, and I'm asking for molecules, a particle. There is no equivalent to get directly there, so we have to go through moles and then to particles. So mass to moles to particles. So we're first going to divide by the molar mass to convert the mass into moles, and then we're going to multiply by Avogadro's number to get to particles. And so we can set this problem up one of two ways. We can do it stepwise. So again, I want to go from grams to molecules. I have to go through moles, so I have to convert grams to moles first, and then moles to molecules. Showing it stepwise, if I take the 5.20 grams and I want to convert to moles, I want 1 mole on top, the molar mass from the periodic table of glucose on the bottom. So I divide by the molar mass to get the number of moles. Once I know the number of moles, I can multiply it by Avogadro's number to get the number of molecules. So I've gone from mass to moles to particles. What I want you to do, though, instead of doing this in two separate steps, is to combine the two steps. And so it's the same problem here as here, just instead of two steps, it's one step. So grams to moles, moles to particles. And note, grams and grams cancel, moles and moles cancel. And so instead of writing this down in two separate problems, I'm just showing it in one problem. Okay, let's take this one step further. What if I asked you, instead of how many molecules in 5.20 grams of glucose, I asked you how many oxygen atoms are there in 5.20 grams of glucose? So again, I'm giving you mass. We have to convert to moles by dividing by the molar mass of that substance. Then we have to convert to particles by multiplying by Avogadro's number. And now we're going to take one more conversion and convert it to atoms of oxygen. And for every 1 mole of glucose, there's 6 oxygen atoms. So one more equivalent, 1 molecule of glucose equals 6 oxygen atoms. So grams to moles by dividing by the molar mass, moles to molecules by multiplying by Avogadro's number, and then molecules to atoms of oxygen by multiplying by the number of oxygen atoms per molecule. So again, if we go back to our mole map, get it here in a second. Okay, we're given grams and we want to get to atoms of oxygen. So we have to get to moles, follow the arrow. We have to divide by the molar mass of the substance, here glucose. Then we have to get from moles to particles, follow the arrows. We have to multiply by Avogadro's number. Then we have to get to atoms, and there's 6 oxygen atoms per molecule. So we have to multiply by 6. I hope that helps.